Professor, you are muted.
Professor, yes.
Exactly, and I was just saying if anybody had any objections with the recording of this session, please let me know. So we will be recording this session. If anybody has any objections, please say so now. Okay. So let's do some exercises, kind of.
Professor, I have a question.
Oh yes, go ahead.
Was it only the two links you sent, right? It wasn't the
Yes.
third one.
No,
Okay,
yes.
perfect.
Just the first two that's basically have to do with the first two laws of Kirchoff. The third link, we're gonna work on that one maybe on Friday or Monday. The third one is some a little bit more advanced problem. So it's just the first two. Okay, so we're going to be reviewing Kirchoff's laws with some exercises, kind of to reinforce the concepts. And remember, we've got two laws here of Kirchoff. One that has to do with Kirchoff's current law, or the first law, or the law that has to do with nodes or junctions, and Kirchoff's second law, which is the Kirchoff's voltage law. First one is usually referred to as KCL. The second law is KVL. So let's get to it. So I'm going to jump over to each of the web pages and go through the exercises. Remember that these, I believe these are going to be random. So I'm going to ask you guys when we see one to kind of go through your notes and let's see what the answer is together. Okay, so I'm going to go to the first.
Professor, have you before used Khan Academy or no?
Yes, I've used it before.
Okay, it's because sometimes they give you different problems depending on the link. Like maybe I didn't get a problem that another team got.
Oh, let's see that. I don't remember that happening last time that I used this particular link. I do remember that the problems weren't in the same order.
Yeah, the problems are in the same order, but before, well, when I was in high school, we used to do homework on Khan Academy. And before, like my first try didn't have the same problems as my second try. So I don't know what's going to happen.
This is part of life. Things are and we're recording this, so if things don't go as we wish, we're going to have it recorded. I went into the link. This link, I opened it today 2 times and the same problem came up. So again, let's see what happens. If not, it's still going to help us review the concepts. So this is the this is the first one. This is the junction rule. This is the first one. And so we've got a circuit here that has 3 resistances, R1, R2, and R3. We've got a power supply here, and we've got a power supply here, and we've got a set of currents that are identified here. I1 corresponding to R1, I2 corresponding to R2, and I3 corresponding to I3. Another piece of information that's given to us is that R1 is larger than R2 and is larger than R3. It's just information that's given. And so it's asking us, what is true about the current through each of the resistors? And we've got 4 options here. What can we say about the current through these resistors? Anybody? Did you get this problem? You should have.
Yes.
Yes. So what would be the answer here?
The D.
D. I think it was Mariana that spoke.
Yes.
Yes, correct. I believe it's correct. We're going to see here. Why? First off, why do you think it's D? And after you answer, I'd like to ask if anybody has a different opinion.
Well, sorry, I think it's D because, well, they're in a loop and like, I don't know how to explain it.
Well, what type of connection do we have there of the 3 resistors? How are they connected?
It's a series, so it has the same current. That's why it's equal.
Correct. It's a series connection. The 3 of them are in series. And we know that when we have elements in series, the current is going to be the same. again, remember, imagine it's kind of what you were saying, Mariana. This is in one sort of loop here, and there's nothing that's making the current go anywhere else. Okay, so what's happening here, and remember again to imagine this like some piping that has fluid in it. There's this pump that's providing fluid that's going through this tube, then it's going through this tube, and then it's going through this tube. So it's the same flow that's going through the three of them. Everybody see that? Okay. Now, yesterday that JC and I were exchanging messages at midnight, we were talking about series and parallel connections and some confusions there. So how do we know this is a series connection? Because all of the components are connected one after the other, and there isn't anything that's separating or making the current go anywhere else. What makes the current go somewhere else? A junction or a node. So for example, if I were to do this, for example, I were to add another, loop here. The fact that I've got a junction here and a junction here would invalidate what I just, what I had drawn in blue. If there were a junction there, then that junction would make the current separate at this point. One part of the current would go this way and another part of the current would go the other way. That would mean that these three are not connected in series. So it's clear to everybody that they're in series, and because they're in series, it has to be the same current in the three resistors. Is that agreed? Does anybody have a different approach or opinion about that? It's not about opinions, it's about facts, but I'm just curious if that's clear or anybody has a different idea.
No, yes, it's clear.
It's clear, Professor.
So this would be D, okay? And that is correct. And Khan Academy is saying nice work. Keep going. Okay, let's go to the next question. Oh, now we're getting a little bit more complicated. Now we've got a circuit that's got 4 resistances, R1, R2, R3, and R4. We're given the same information. R1 is larger than R2, and it's larger than R3, and it's larger than R4. Okay, the 3 currents are the four resistors. I'm sorry, are larger than one is larger than the next in the consecutives. Okay, and they're asking us about the current through each resistor. Did you get this problem?
Yes.
Yes.
Now, you know what,
Yes.
going back to Lucia's comment, I remember what happened. Well, question, was this the second problem for you guys also?
Yes.
Oh, now I remember
Yes.
what happened, Lucia, for this, because I've already used this link in particular. What happened, Lucia, for this link, the first time I used it that I didn't know about Khan Academy, is that now I remember, the problems were in the same order, but the answers were different, were mixed up. Right, so in the last one it was D, but depending on the link, I think that it isn't necessarily D for everybody. I think in one of the links that's what happened. But okay, you guys had this one. So for the circuit shown, the resistances are one larger than the other, and we've got 4 currents there, and they're asking us to see which of the statements is correct. Now, tip, you guys, when we have a multiple choice exam or question, we have to try to develop skills where we find the answer by a sort of a process of elimination, okay? And the process of elimination is to be able to identify what things we're sure of and identify them in the answers, and things that are definitely not true that would eliminate some of the answers, okay? So how would we approach this one? Anybody want to give it a shot? What would we do there?
The best way I can explain it, I mean, so first of all, I1 and I4 are in series, and well, we know that the same charge that goes into the circuit needs to go like around.
Correct.
So
So
I
let's
one and I4 would be equal.
that's correct, Leonardo. That would be our first assumption. This section here, these elements are these three elements are connected in series. They're not in series with R3 or R2, but amongst themselves, they're in series. So this means that I1 is equal to I4, right? That is a correct assumption, Leonardo. So by process of elimination, we would eliminate this one and eliminate this one. Would you agree with that, Leonardo?
Yes.
Okay, good job up to this point. So we've got now C and D. How could we know what's happening there?
I mean, the best way I can explain it, I2 and I3 are in parallel, but I3 is first, so I3 should be bigger. So it's D. Oh no. Okay, so since they're in parallel, they cannot be equal.
Yes, that's a
Charge it
first.
down.
Yes, let's go step by step. Correct. Well. Let's dig into that because this could be a question in the exam. Okay. First off, correct, Leonardo. They're in parallel. So the next thing we have to understand, if the connection is a parallel connection, is that this current that's on this side is going to be divided. Remember that parallel connections divide current. So that means that there's going to be one current here that's I3, and there's going to be another current here that's called I2. Now, you just said that they can't be the same. Actually, they can be the same. What is going to be the factor that's going to tell us what relationship those two currents have in the division? So we've got two elements here connected in parallel, and we've got
resistance.
The resistance is cutting, correct. So actually, if both resistances were the same, if both resistances, R3 and R2, were equal, then the current would be the same. So remember the concept of resistance. Imagine you've got a tube, a piping, and the resistance is a constriction or making the tube, the pipe larger or smaller. Depending on the constriction is the amount of flow we're going to have. If the constriction is exactly the same, then the separation is going to be the same. So, Leonardo, just to correct that part, if the two resistances were the same, the flow would be the same. Okay? However, are the resistances the same in this case? No, they're not. R3 is larger than R4, R2. Okay? So, even though this is correct, this is not. Okay? Are we okay up to this point?
Yes.
So by default, the answer is D. But let's try to understand what D is saying. So I1 and I4 are the same. So there's this current going here, and it's going to separate into two parts. Okay? So first off, if the current is going to separate into two parts, that means that this current is larger than whatever comes afterwards, than the separation. Okay? Now another thing, but which of the two currents is larger? Well, can somebody tell me of R2 and R3, which of the two resistances is larger?
On the
R2.
R2.
R2 is larger. Is that clear to everybody? It's stated here in the problem. R2 is larger than R3. If the resistance is larger, am I going to have more current or less current?
Less current.
Less current, correct, Omar. The larger the resistance, I'm resisting the flow of current. The larger the resistance, the smaller the current. So that means that if R2 is larger than R3, R2 is larger than R3, then that means that the larger current is going to go to what resistance? Again, if R2 is larger than R3, then where is the larger current going to be?
R3.
R3.
Professor,
So,
but
yes.
that does not matter when they're in series.
No, where they're in series, the resistance value doesn't matter because the current is going to be the same. So
Okay.
this relationship is important. R2 is larger than R3, but because the relationship is inverse, so the larger the resistance, the smaller the current, that would mean that I2 is going to be smaller than I3, which is basically what we have here. Okay. So the answer should be D. Okay.
Yes, sir.
That is correct. Yes, Ivan, go ahead, please.
So it doesn't matter that R3 is closer to the rest of the circuit.
No, we could have, that's a very interesting question, Ivan. We could have flipped these, by the way. We could say that this is R3 and this is R2. Okay. For the purpose of the analysis, the only thing that would happen is that these relationships would be flipped. But the position of the resistor, in the case of a parallel, it doesn't matter because the order of those factors doesn't affect the result. The same as in a series, it doesn't matter how or in what position in series they are, the current is still going to be the same. So if it were R2 and R3 or R3 and R2 the other way around, the result is going to be the same. Okay. Is that clear, Ivan?
Yeah, thanks, Professor.
Okay, good. So questions with this one before we close up?
No.
Okay, good.